Hi everyone, this is the video of differentiating the trigo function. For first question, first example, I have a three sub question over here, A, B, and C. It's a very simple question. First of all, we need to know the formula. If we have a y equals to sine x, dy dx, you will get cos x. You need to remember this formula first before you proceed to the question. If a y equals to cos x means that the dy dx will be equals to negative sine x, and y equals to tangent x, you have your dy dx equals to secant square. Those are the basic trigo function. Alright, with the angle is the x. Now, for the question A, y equals to 3 sine x. To find the first derivative of this function, first of all, look at the function containing the coefficient 3. So we just copy down the coefficient first. Then to differentiate the sign, we have cos according to this formula. Alright, so this is our answer. And the question B, 5 cos x. Y equals to 5 cos x. To find the dy dx, again, I will copy down the coefficient first, that is 5. And differentiate the cos, you have your negative sign. Then we need to simplify, you get negative 5 sine x. Alright, then last question, C, y equals to negative 3 tangent x. To get your derivative, dy dx, again, the coefficient, just copy it down. And differentiate tangent according to this formula, you get a secant square. Okay, so this is the answer. For the question 2, part A, y equals to sine 5x. If you have this question, I will just treat this 5x as my inner function and the sine as the outer function. And actually, you are applying the chain rule. To get your dy dx, I will first differentiate the outer function, which is my sine. Differentiate sine, you get cos. And the inner function, just copy it down. Then multiply by, differentiate the inner function, you get 5. Finally, you have a 5 cos 5x. And for the question B, the outer function, okay, this is the first function that we need to differentiate, that is outer function. And the inner function, I would make it as a second function that I need to differentiate. The dy dx, firstly, you need to differentiate the first function, that is your cos. Differentiate cos, you get negative sine. And the inner function, you just copy it down. Alright, then now you need to multiply by, differentiate the inner function, which is your x squared, you get 2x. Then you simplify. Negative 2x sine x squared. That is your answer. For the C, example C, dy dx will be equals to the outer function. I will make this as a I will set as a 1, means a tangent as a outer function, and the inner function I'll set it as a second function that I need to differentiate. So the first function that we need to differentiate is tangent. Differentiate tangent, you get secant square. And for the inner function, you just copy it back, okay, because now you differentiate tangent, you get secant square. Secant square of the 4x. Okay, because the 4x as an inner function, you just copy it down first. So now multiply by, yes, second, now it's a turn to differentiate the 4x, you get 4. Differentiate 4x with respect to x, you get 4. Then rearrange it. You get 4 secant square 4x. The fourth example, D, to get a dy dx, firstly, if I have a coefficient here, I just copy it down first. Then I have my sine x squared. Sine x squared, I will define this sine as my first function I need to differentiate. And the second function that I need to differentiate is x squared. That is the second function. Okay. Now, differentiate the first function, sine, I got my cos. And the x squared, just copy it down. After that, differentiate the inner function, you get 2x. Then you simplify, you get 6x cos x squared. That's it. For the example D, here is the coefficient. So firstly, to get dy dx, just copy down the coefficient, and then consider your outer function is tangent, inner function is 4x. Differentiate the outer function first, tangent, differentiate tangent, you get secant square. Secant square of 4x, just copy it down. And multiply by inner function, differentiate the inner function, you got 4. Then we simplify your answer. For the question 3a, so now on my inner function, I will set my outer function as the first function, that is sine. And the inner function is x plus pi over 2. Pi over 2, bear in mind that is a constant. So now to get the f prime x, we differentiate outer function first, which is the sine. We got differentiate sine, you get cos. So this, what is inside the bracket, you just copy it down without do anything. Alright, because you are differentiating the outer function from the sine, you have cos, and whatever inside here, nothing changed. Alright, then after that, you need to differentiate the inner function, which is the second function you need to differentiate. Differentiate x, you got 1, and differentiate pi over 2, you get 0. So actually, the answer is 1 multiplied by cos x plus pi over 2. Final answer, you get back your cos x plus pi over 2. Alright, so for this example, B, the outer function I will set as a first function, which is my tangent. And the inner function is a 3 minus 2x. I put it as a 2, and this is 1. To get your f prime x, again, we differentiate from the outer function to the inner function. Outer function, differentiate tangent, you get secant square. Secant square of whatever inside the bracket, you just copy it down. Alright, and then after that, multiply by, differentiate the inner function, you get negative 2. So rearrange your answer so that it look nicer. Then this is your answer. For this question, I will rewrite this fx into 4x cos 4x plus 3 power of 1 over 2. Alright, means that my outer function is a cos and my inner function is a 4x plus 3 power of 1 over 2. Okay, so we start to get your f prime x. Set your outer function as cos, meaning that you need to differentiate cos first, you get negative sign. Alright, and then here I will just replace back this 1 over 2, power of 1 over 2 with square root. And now I need to differentiate the second inner function, which is differentiate the 4x plus 3 power of 1 over 2. How do you differentiate 4x plus 3 power of 1 over 2? You will bring the 1 over 2 to the front, and then the power minus 1. Okay, then you will copy down whatever in the bracket, copy it down, then multiply by, differentiate the 4x plus 3, you will have a 4. Here you can see that the 2 and the 4 can be cancelled off. Then you rearrange your answer, you will have 2, negative 2 sine square root of 4x plus 3, and then divided by square root of 4x plus 3. So bear in mind that this is a sine square root of 4x plus 3, and this is a square root of 4x plus 3. Please don't go and cancel it. Sine square root of 4x plus 3 is considered as an individual. You cannot just separate them. For the question 4, I got 4 questions. So we just name our function as a y. Okay, and then to get your dy dx, we just differentiate term by term. Differentiate cos, you have your negative sign, and differentiate sine, you get cos, just like that. And then again, I rename my function as a y, and dy dx will be equivalent to differentiate the 3, you get 0. Then here you have a coefficient negative 1, just write it down. And after that, differentiate the cos, you get negative sign. From here, you have negative multiplied by negative, you have positive sign. For question 4c, again, I name this as y, and we will find the dy dx by differentiating term by term, coefficient 2, just copy down. Differentiate sine, you get cos. And then plus 3 over 2 is your coefficient. You just copy down first. Then you consider to differentiate the cos theta. Differentiate cos theta, you get negative sine theta. Then you simplify your answer. Minus 3 over 2 sine theta. Okay. Then the same for the d, I will name this as y. To get my dy dx, coefficient, copy down first. Differentiate tangent, you get secant square. Then copy down the negative 3. Differentiate cos, you get negative sine. Then simplify your answer. Plus 3 sine theta. Okay, so for this differentiation of trigo function, I got 3 more questions, which is question 5, 6, and 7. I will put it in my next video. Thank you for watching.